All right, welcome to week 6, new 36, simplifying square roots with no variables. Let's get started. So there's multiple ways to do this. I'm going to show you the way that involves using that diagonal from your multiplication sheet. Or your multiplication chart. So if you want to make sure you have that printed out and kind of next to you or near you, a calculator is also helpful, but again, a calculator, your multiplication chart, and this worksheet are all you really need. So with this, from this point forward, when you see a square root, you're not going to want to get a decimal answer, and we kind of talked about that at the end of the last video. So we know that if we were estimating the square root of 24, it would fall somewhere between the square root of 16 and the square root of 25, which is somewhere between 4 and 5, closer to 5. So probably right around 4.9, 4.8, 4.9. But what does this look like simplified, not using decimals? Well, we want to again use those perfect square numbers. So 1, but 1 will not really help us a lot in this. So we want to use these 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. They keep going, but most likely you'll need numbers that are way less. Now, the key to making your life easier is to find the biggest perfect square that divides out. So if we look at 24, 24 falls right in between there. We just said that. And that's why we do that exercise on the previous paper, because it gets us thinking about where that number falls, where that estimation occurs. So we want to say to ourselves, 24 divided by 16, does that work without a decimal? No. 24 divided by 9, does that work without a decimal? No. 24 divided by 4, does that work without a decimal? Yes. Now you might be saying, why are you skipping all of the other numbers? Because the only numbers I care about are my perfect square numbers. And again, 1 is not really going to help me here. If none of these numbers work, then I have one that can't be simplified, and I can leave it unsimplified. So we might see that. But for this one, 4 works. So I rewrite this as the square root of 4 and the square root of 6. Now, where did the 6 come from? Well, the 6 was my other number, right? So if I divide 24 by 4, I get 6. 4 times 6 gets me back to 24. So you see where this is, again, where these factors come into play. 4 and 6 are factors. Okay, 4 and 6 are factors of 24. And if they're both, at this point, they're both still under a square root. Okay, they're both still under the square root. So if I were to multiply them together, they'd both still be under that square root. So the square root of 4 times the square root of 6 equals the square root of 24. So I can rewrite the square root of 24 as the square root of 4 times the square root of 6, or the square root of 4 square root of 6. Again, I put the 1 from my list over here. This list. Okay, that's the important one because that's the perfect square. That's the one that simplifies. So that one always goes first right here. And I usually, if you were to look at my paper, I circle it because that is the one that, again, is simplifying. So the square root of 4 turns into a 2. The square root of 6, nothing can happen to that. So I leave it. And my final answer is 2 square root 6. And I'm all done. All right, so now looking at the next one, root 27. Okay, estimating puts me right here between 25 and 36. So again, I'm right in between there. So if I'm saying to myself, what divides into 27? Well, it's not 25, it's not 16, it ends up being 9. So if I write this out, it's the square root of 9. And 27 divided by 9 gives me 3. That's how I find my leftover. I do 27 divided by 9 gives me 3. That's my leftover number. Okay, I circle this one. The reason why I circle that one is because it was on my list right here. That's my perfect square. The square root of 9 turns into a 3. 3 root 3, and I'm done. The reason why this one doesn't change is because that one is not a perfect square. That number is not on this list. So the square root of 3 stays the square root of 3. The square root of 9 is on that list right there. So that turns into a 3 with no square root on it anymore because the square root of 9 equals 3. All right, let's look at 45. So 45 falls right here. So now I need to think, okay, does 36 divide into it? No. 25? No. 16? No. 9. Again, it's a 9. So it's the square root of 9. 45 divided by 9 gives me this other one. And what's my other factor? It's 5. 9 times 5 gives me 45. I circle this one because it's on my list. That's why I always write it first, because it's signaling my brain to remind me that it's my perfect square. It's the one that's going to simplify. It turns into a 3, and I leave the square root of 5 as is. Now look at this next one. I have the square root of 30. The square root of 30 falls right about here. Okay, in between 25 and 36. Now, if I say to myself, okay, I can divide by 25, that doesn't work. Divide by 16, that doesn't work. Divide by 9, that doesn't work. Divide by 4, that doesn't work. I already said 1 doesn't help me. So this is a perfect example of one that, even though it's kind of a large square root that doesn't simplify, it in fact does not simplify. So you can leave it as the square root of 30. Now you want to rewrite it, because if you leave it blank, it appears to the person grading your paper that you didn't know what you were doing and you left it blank. So you want to rewrite it as the square root of 30 and be on your way. All right, I might have to move my list down, or I can kind of create my list again. I have 4, 9, 16, 25, 36, 49, 64. Those are the first 7 or 8. All right, 18. Well, 18's right here. So 18 divided by 16, that doesn't work. 18 divided by 9, that works. So I do root 9. 18 divided by 9 gives me 2. So that's my other root. Root 9 times root 2 gives me root 18, so I know I'm good. Root 9 is the one that simplifies. Root 9 simplifies into a 3, and it's 3 root 2. Now, here's an example, and I will show you, for these purposes, the 2 ways of doing it. Now, some of you off the top of your head might think, like, if you're not doing it the way I'm showing you and you're just kind of going all willy-nilly, 4 works. Root 4, 8, that simplifies, and you get 2 root 8. Well, yes, you're totally correct, but guess what? You are not done, because then 8, you can continue on, because you can take a 4 out of 8 again. So then you'd have to do it all over again, and you'd have to go 4, 2, that turns into a 2, and that turns into a root 2, or stays a root 2. But then you had this 2, so that has to come down, and then they have to get multiplied together, and you have to have 4 root 2 at the end. Okay, now, what you could have done from the get-go is looking at this. 32 falls here between 25 and 36. You say to yourself, okay, 25 doesn't work, but 16 works. So when you have 16 working, you get root 16 and root 2, because 32 divided by 16 gives you 2. And then root 16 turns to a 4. The root 2 stays a root 2, and it ends up being 4 root 2. And you get to that in less steps than it took you the other way. So with this, you always want to find the biggest perfect square that divides out of your square root that you're simplifying. All right, let's try some on the next page. All right, 75. Any of the ones that, are quarters, and when I say quarters, like these are your money terms, like 25, 50, 75, $1, $1.25, $1.50. Those you're really looking at 25 or 100, right? So if I list those numbers out for me again, knowing that one doesn't help me. All right, 75 is all the way up here. 64 doesn't work, 49 doesn't work, 36 doesn't work, but 25 works. And when I divide out 25 from 75, I get 3. Root 25 turns into a 5. Root 3 stays, and I get 5 root 3. Now, with 128, this is a perfect example of wanting to find the biggest one. All right, so you're going to want to make sure that you find the largest perfect square that divides out of this one. This one sits all the way up here between 121 and 144. 121 doesn't work, 100 doesn't work, 81 doesn't work, 64 works. And when I divide 64 into 128, or 128 divided by 64, I get 2. So I have root 64, root 2. Root 64 turns into an 8. So my answer is 8 root 2. Now, when I'm saying to you, like, 121 doesn't work, 100 doesn't work, 81 doesn't work, 64 doesn't work, that should not be as quick for you. It's quick for me because I know for a fact it doesn't work because I've done these over and over again. That's like the time lapse feature in my video without time lapsing. So that's where, you should be trying these on your calculator. You should be looking in your multiplication chart to see if those, it's a factor of those numbers. Take time to practice, doing the 128 divided by 100, 128 divided by 81, 128 divided by 64, and looking to make sure, like, okay, I got a decimal, it doesn't work. I got a decimal, it doesn't work. I got a decimal, it doesn't work. Oh, I didn't get a decimal. That's the one I want. Because then it's going to end up giving you good practice for what you're doing. All right, now what happens when something like this happens? Root 25, well, 25, if I look back up here for a second, 25 is on your list, okay? And when it is on your list, it's on your list. I mean, it's a perfect square. So there is no two ways about it. It is just, that's it. It's 5. All right, 96. 96, if I move up, just so I don't have to write my list one last time, okay? 96 is right here between 81 and 100. If you divide out or divide into it, 81 is not going to work, 64 won't work, 49, 36, 25, it's going to end up being 16, and it'll be 16 and 6. The 16 turns into a 4, and when I say turns into, it really simplifies. Root 16 equals 4, so it is 4 root 6. All right, so go ahead and give these some practice. Next up will be variables, so make sure you understand it with the numbers before we move on to that. And I'll see you back here for it.